today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're going to be looking at paper 2, a revision, which has the following topics that we're going to look at today. So we're going to look at analytical geometry, which is plus minus 25 marks, of which out of 25 marks we can at least minimum of 20, we must get that. We're going to look at trigonometry, which is 50 marks, which I think most of you learners, you find this a bit challenging, but today we're going to make it very simple. So we're going to make it look very simple. We have the next topic which is Euclidean geometry, which is plus minus 40 marks, and this is one topic that we really need to understand the theorems and also understand the statements and the reason that we give. So the reasons that we give in this section is very important. But if you know the statement and you don't know the reason, at least you can get 1 out of 2 for that question. We're going to look at circles, angles, and angular movement, which is plus minus 25 marks. And then in this topic, it's nice because all the formula that are given there are also indicated that this is the formula for angular velocity, this is the formula for arc length. So we are able to be able to pick up which formula we want from the question that has been asked. We have measurement, which is plus minus 10 marks, which is a bit challenging because then they give you different questions every now and then. So you just need to understand the formula and how to substitute the formula and how to apply that formula. This is just an information sheet on the analytical geometry. So when you go into the exam on Monday, please try to identify this formula. Please don't go and study the formula sheet. It is not necessary. You'll be given the formula sheet, but just look at the formula sheet and try to identify which formula is for what. In this case here you have, first of all, the distance formula. You'll see the distance formula has got a d without the square root, and then from there it's equals to this part here squared x2 minus x1. Please, if you say x2 minus x1, here it must be y2 minus y1. They must be both squared. There's a plus sign in between here, and you must copy it correctly from the formula sheet. The next one is the midpoint formula, which sometimes we confuse it with that m. This is the m without the equal sign, so which has x1 plus x2 over 2. So we need the middle point here, which is between the 2 points x1 and x2. And then from there it must be y1 plus y2 all over 2. The other m here is for the gradient. So the gradient, remember when you write y equals to mx plus c, that m is for the gradient. So the gradient will be y2 minus y1 over x2 minus x1. So we'll have that formula as a gradient formula. So the m here. So if for instance I have m over 1 and I cross multiply, then I get the equation of the straight line. So if you look at this, it will be y2 minus y1 equals to m multiplied by x2 minus x1. So if you look at this, that formula is like that. This month we must have brackets around that. So we have that part of the formula. So you can see it's y2 and x2, so it's the same formula from the gradient formula. So please don't confuse the midpoint formula and the gradient formula. Right. Let's look at activity 1 in analytical geometry. Just take your time and read the question. It's very important. Some of the information will be hidden in the statement. So let's read the statement and make sure that all the points that they're saying are exactly what is on the sketch. It is very, very important. Now it says the diagram has vertices R, so we go to R minus 5 and 3. So we go to R and check, is it minus 5 and 3? Yes. We go to S, which is 4 and 5. We go to S there, which is 4 and 5. T, it's X and Y. T, it's X and Y. U, it's 1 and minus 6. 1 and minus 6. Now it says theta is an angle of inclination on line RU. So line RU is this one, here's the theta, right? That is the angle. Remember, the inclination is an angle between the x-axis and a straight line. So it's that angle. It's between the x-axis and the straight line. So going to the exam, given that angle, you must always know that it is an angle. So you can see that that angle is bigger than 90. So it's in if it's bigger than 90, so which means that I'm going to be looking at an obtuse angle, so I need to do some reduction. Now it says TU is parallel to the x-axis, so we look for TU. TU is there, so it's parallel to the x-axis. Nice. Again, say ST is also parallel to the y-axis, so the ST here will also be parallel to the y-axis. Okay. Now, why this? It will help us somehow. How is that going to help us? Because I know that this line is a straight line. If this point here is minus 6, so it means that the y value here will be minus 6. Now, if this point here is a 4 on the x, which means if this line is parallel to that, it means that that line, the distance between that and the distance between this will be the same. So it means that that point will also be 4. Oh, nice. You see how that one will help us. So now I know t coordinates will be 4 and negative 6. Okay. All right. Easy. So when you go into the exam, you must read the statement, check the information that is on the statement, make sure that it is there on the sketch. If it's not there, please include it on the sketch. Like here, TU is parallel to the x-axis was not included, but I just included there on the sketch. Because I know that if this line is parallel to that, no problem. The distance between this and that is the same as the distance from there to there. The distance from there to there is the same as the distance there, is the same as the distance there. So I'm able to then check. Okay. All right. Now, in the next question, still on the same sketch, it says the length. So what do you know about the length? It's the distance. It's the distance between the 2 points. So if I'm talking about RS, R to S, do I have coordinates there? Yes, I do. I need the distance of that line, the length of that line is the distance between this point and that point. So which means I'm going to say my distance, which is D, in this case, I need the distance of RS. So remember, it's D, it's equals to. So I can first write down the equation to show the markers that I know what I'm doing. You can write the distance formula and say D equals to square root of. So here I'm going to write RS equals to the square root of. So which means if I start with the X on the R, I must also start with the X on the S. So if I say minus 5, then I'll say minus 4 squared. All right? Then from there, you remember there's a plus sign. Then I'll say, then the 3 and the 5. So it will be 3 minus 5. Can you see what I've done? I've started with the point R and the X values and the Y values of point R. Then I subtracting the point values of X and Y from point S. Then from there, immediately here, you just take your calculator. Go to the calculator and you press square root, open bracket. I hope you're doing it with me. Some have already got the answer, I know. Minus 5 minus 4 all squared, close bracket, all squared. And then from there plus, open bracket, 3 minus 5, close bracket, squared, and I must get my answer there. So my answer will be 9,22. It's 2195. So that will be 9,22 units. Right. So that is the length of DS. So you can see there, you're going to get marks for the substitution and mark for the answer, which is 9,22. Okay. Remember, all answers with decimals must be correct to 2 decimal places, unless it is stated otherwise. Now, 1.3 says calculate the midpoint. Can you see those formulas that I've talked about? They are there. I've already used which formula and which formula. I've already used the distance formula. Now they're asking me the next one is the midpoint of the line. So you must check those questions and understand the formula sheet. So this weekend you must understand the formula. I'm not saying go and study the formula sheet. I'm saying you must understand which formula is for what. So here the midpoint. Remember the midpoint is that capital letter M. Then from there I'll have the bracket. Then from there first I'll have the x1 plus x2 over 2. The other one will be y1 plus y2 over 2. It's good that you write down the formula, and then from there you go you go and substitute. So my gradient will be, so it is for which line here? RS. So RS, I need where that M is. I don't know where it is. I don't want to put it there before I calculate it. But I'm using point X here and point X there. So I'm going to have minus 5 plus 4. Remember, now we are adding over 2. The y will be 3 plus 5 divided by 2. Okay, so from here, just go to your calculator. Minus 5 plus 4. Now that's easy. I think it's minus 1 over 2. 3 plus 5 divided by 2, that will be 4. Now let me go and check if this point can make sense on my sketch. So the x value here, it's minus half. So probably maybe minus half will be somewhere there. I'm just guessing. Right, now let's look at where this point here will connect with that line. So here it says the y value will be 4. So probably this point here will be 4. So that could be the midpoint. Can you see? That could be the midpoint. Negative 1 over 2 and 4. And I know that, probably I might be right. I know I am right. So if my point was something else, like half and 5, for instance. So half will be somewhere there, 5 will be somewhere up there. So I'll not be correct. So it is very, very, very important that you take your answer and take it to the sketch and make sure that put that point in there and see if that point, especially with the coordinates, make sure that that point is correct. All right. Now, the size. So size is nothing else but the inclination. So when we talk in analytical geometry, those angles that are formed between the axis and the line and the straight line inclination, right? Now, it says correct to 2 decimal places. You see now it's stated, correct to 2 decimal places. So I need the angle. What do I know about the inclination? Inclination is nothing else but the tangent of an angle equals to the gradient of that line. So the gradient of that line, so it's the gradient of that line here. So it will be the gradient of RU. I'm just putting it out there. So what do I do first? What do I do first? I must first get the gradient of RU. Because I don't have the gradient of RU. Never calculated it. In some instances, you find that you have calculated it. Please do not recalculate it. You just input it. Right, RU. So R, the gradient. You see now they're asking me another question here, the gradient. So the formula for the gradient I'm going to use now. So it's y2 minus y1. So if I start with y here, minus y1, so it's negative 6 over, I must start here again. So it will be negative 5, negative 1. So I'm going to get 3 minus 6 will give us a positive 9. Minus 5 minus 1 will give you a negative 6. So the gradient of that will be negative 6, 9 over 6. So I'm going to write tan of theta is the gradient. So it's negative 9 over. Now, remember I need an angle. So how am I going to get an angle? So first, I must now say theta will be equals to, remember, no, you love this because you love your calculators. Inverse of that. What you put inside, if it's a negative, you just put it as a positive. You don't put it as a negative. I'll explain why at the end. And you know you've been doing these things and you've been practicing, we know. The skill here that we need the tip that I can give you here is that when it's a negative, put a positive inside. I know, you know, with the teachers, when you're working with the teachers, they'll just say, you can do it as a plus, as a negative, and add plus, and add 180 degrees. But anyway, let's do it this way. Here's a good skill. Then from there, you go to your calculator and say shift tan. We can do it together now. You can say shift tan. Then from there, 9 over 6. Then the angle that you're going to get, it's not theta. The angle that you're going to get is called a reference angle. Please do not write theta. You're confusing the markers because the markers are looking for theta and you've written theta at a wrong place, which is a reference angle. So what do? We write a reference angle. When we have a negative in there, we're going to write a reference angle, and my reference angle is going to be 56.31. Remember, they said correct to 2 decimal places. Then from there, I can say, therefore, my theta will be, then because it's an obtuse angle, it must be 180 degrees minus the reference angle. Then this is theta. So my theta is going to be 123.69. That is my theta. So the theta is that angle. Because if you come here and say theta, it's 56.31. Are you saying that that angle is 56.31? No. That angle here is a reference angle that I'm going to use with my reduction formula, which is 180 degrees minus theta. Please, let's write it correctly and we must not confuse the markers. Okay, right. 1.5, it says determine the equation of the line. Immediately when they say equation of the line, what do you know? You have your formula, y minus y1 equals to m into x minus x1. Why don't I just write down the formula? I mean, if this question is 3 marks and I've written the formula, they're marking the formula, for instance, I already have 1 out of 3, which is 33%. I've already passed. I just copying the formula from the formula sheet. But it must be the correct formula. So, but they say, the line is passing through the midpoint of P. Oh, remember the midpoint M here? It was how much? -½ and 4. Oh, I still remember it. Now, it says that line is passing through that line of RS, and that line is perpendicular. Now, they say there's a line which is perpendicular, it's passing through here. I don't know whether the way it is passing, but at which point, but we just know that it's passing through this and it's perpendicular. I love this question. Now, what do I know about perpendicular line? The product of their gradients is -1. So meaning that if I've got line 1, this is line 1 and that is line 2, the gradient of that line times the gradient of that line will give us -1. So if I know one gradient, then I know that. Now, what is the gradient of RS? That's what we need now. Now, the gradient of RS, I don't think we got it. We did not do any gradient of RS. Not done yet. So now let's get the gradient of RS. So the gradient, we start with the y, remember? It's 5 minus 3. If I started with the 5 minus 3, I must start there. 4 minus 5. So the gradient of that line is going to be 2/9. That is the gradient of RS. Now, if I know the gradient of RS, which is 2/9, then the gradient of this line, which is perpendicular, which I don't know. So the gradient of the perpendicular will be, remember, if I multiply the gradient of RS times the gradient of the perpendicular, I must get -1. So, which means that I just take this. Here's a scale. It's positive. I turn it around. It becomes 9/2. Because it's positive here, this will be negative. Okay, so that is the gradient. Once I have the gradient, I can be able to get the equation of the straight line by using this point here and the gradient. So remember, if I've got a gradient and a point, I can get the equation of the straight line, easy. So now I'm going to have y minus my y1 is 4. The gradient now it's -9/2. X remains. My x1 is this, so it will be negative, which is positive. Then from there I can write it. They didn't even say we must write it in the form y equals to mx plus c, but I know the standard form there. The standard form will be y equals to mx plus c. 9/2x minus 9/4 plus 4. Where did I get the plus 4? It's a -4 transposed. So my final answer will be y equals to -9/2x. And then that should be plus 16, so there will be 7/4. That is now the equation of the straight line in a form. Remember, it is the equation of the straight line. So how should I get the equation of the straight line? You need the gradient and you need a point where that line is going to pass through. Very nice question, this one. So in this question, this is grade 11 work. This is grade 11 work. Remember in your question paper on Monday, the first question will be based on grade 11 work, and probably one question that you have done in grade 12, but basically it will be grade 11 work. And the next question here, which is activity 2, will now be based on the circles that we have done in grade 12. Right. In this case here, we must read the information. The diagram below, 0, 0, in the diagram below, that is the center of the circle, is defined by that. So already they've given us the definition of that equation of the circle. What is missing? It's only the r squared. Okay. They say QR is a straight line. This line, they say this line is straight. It touches the circle once. Oh, to give me an idea. Touches the circle once at M4 and -5. So that should be a -5. So 4 and -5. So the 4 is positive, the 5 is negative. So now, what is the name? I've never seen a very, very easy question like this. What is the name given to the line QR? They've already given you a hint. I can hear all of you in Gauteng saying that line is called a tangent. So it is a tangent. What has given it away? It touches the circle once. So it becomes a tangent. And that is a beautiful mark that everyone must get if that question is asked. So you already know that, oh, okay, if that line touches once, it's a tangent. If it touches twice, it becomes a secant, you see, because there it touches twice, then it becomes a secant. Okay, let's go on with the question. 2.2, determine the equation of the circle. Already I'm given the equation of the circle, which is x squared plus y squared equals to r squared. So I'm given that equation, x squared plus y squared equals to r squared. But what do I have here? I don't know what is my radius, but what do I have there? I have the point x and y, my boys and girls. So it means what is missing on this question is the r. So I'm going to input these values as they are on the x and the y. My x is 4. Each and every one of you must get this question. My y is -5 and it's a square. You don't have to take 4 squared and then just use the calculator, and the calculator will give you an exact answer of 25. I can stop here because already the equation is there. So it's just the replacement of x squared. But because I want to be smart, then I'll go and say x squared plus y squared equals to 25. Please do not get the square root of 25. We're having a lot of learners, when we're marking, that comes here and write 5 here instead of 25. They go there and say square root of 25. But because the 5 is a radius, but the 25 is a radius squared, and radius squared is not equal to the diameter. The diameter is 2r, not r squared. So if I need the diameter of that line, it will be 5 plus 5, which is 10. But the r squared is the radius squared, which is 25. Okay, right. These are some of the little things that you need to understand. Monday, these are the little mistakes that you must not do. You must not do. Don't get the square root of that number unless if it is stated, determine the radius. Okay. If they say determine the equation of the circle, don't take the square root. If they say determine the radius, what is the radius? What is the length from here to there? What is the radius? Length from here to there. Then that's where you can bring in the issue of finding the square root. Right. 2.3, obvious question, calculate the equation of that line. Right, equation of that line. We've got 2 ways. But I've got this equation that I'm not sure if it's not even this formula sheet. I'm not sure if most teachers are using it. But I know Euclidean teachers will be using this equation. Right, it will say x multiplied by x1 plus y times y1 equals to r squared. Already I have the r squared. So my r squared is going to be 25. Then this value here will be my x1. That value there will be my y1. So I'm going to substitute them here. So I'm going to say my x1 is going to be 4 times x. My y1 is going to be -5 times y. Then I'm going to get 4x minus 5y equals to 25. How easy can this thing be? So then we have -5. I need the x on the other side. Minus 4x plus 25. I need the y on its own. Divide everything there by -5 to get the equation. Then this will give us y equals to negative. Divide by negative, it's positive. Negative by positive, it's negative. 25/5. Okay, let me see if I've not done any mistake there. The x value there is 4. We have a minus 4 there. So the radius, okay, let me just quickly go back. There's something there. 16, yes, 16 there. That should be 41. Sorry, that should be 40. Because 16 plus 25, my bad there. So it will be 16 plus 25, which is going to be 41. And that should be x squared plus y squared equals to 41. Right. Then from there here, that should be 41. And that should be 41. You can see the mistakes that we can do as mathematicians. Then from there, this one will be 41. And that one will be 41. So the answer there will be 5. Y equals to 4 over 5 minus 41 over 5. That is correct. Okay. So please, these are some of the things that you make a mistake, you go back to the question and read the question again, and you have the time to do that in the 3 hours to check your work after you have done that. You can see, you can quickly pick up that no, there's something wrong here, that the value there cannot be 5. So the y coordinate, I mean the x, the y-intercept of that graph cannot be 5 there, so that's why I picked up there, cannot be negative 5. Okay, right. So this one will make sense now. That point there will be 41 over 5, negative 41 over 5. Right. Given the equation x squared over 8 plus y squared over 25 is equals to 1. Express the equation in this form where you have it as a square here. Now, the 25 is quite easy. So I can go x squared over, let me see, y squared over, what number can I square to give us 25? So that will be 5 squared. In this case here, it's the same, 25 and 5 squared. 8. What should I do? What number can I square? And it will give me 8. So once we have things like this, so this and that, I can write it as square root of 25 squared. I can write that number like that. So it means that in the 8, I can do the same. So I can have square root of 8 squared, because I need this squares here according to the question. All right. So I can still write it like that there, because I know the square root of 25 is 5, so that's why I return it as 5 squared. Okay. All right. The next question is obvious. Sketch the graph on that given grid. Now, to sketch this, I need the square root of this number, plus minus. The square root of 8, according to my calculator, it's 2,8. So 2,8 is next to 3. And the other one should be on the other side, on the negative side. The square root of 25 plus minus, it's going to be a 5 and a minus 5, plus minus, okay? Then from there, I just join these points by using freehand. My x value is that, my y value is that, my x value is here. I get my 2 points here. Okay, easy question, straightforward. Want everybody on Tuesday. If you want to start with that question, please start with it and get it done. You know you have your 3 marks already out of 150. You're moving. Right. Now in trigonometry, so the analytical geometry, those 2 questions, your grade 11 questions, what you've done grade 11, and also the grade 12 one on circles. information sheet for that. You're going to have the rules. I'm not going to do any question that has got to rules, but you must know these rules, how they apply. You must know these rules, how they apply. You must know the area rule and how. This, you must understand this. This can be asked in any way. They can give you 1 minus cos squared theta, and they say this is equals to. Or they can give you sec squared of theta minus 1 is equals to. Or they can just change this around and take this one to this side and say cot squared theta. So you must practice that. It can be cosec squared of theta minus 1. So practice it. Because these are easy maths that you must get. So if you get something like this, please make sure, just get it right. Okay. The reduction formula, very, very, very important. So you'll realize that when we have 180 minus theta in the second quadrant, check your sign. Always check your sign. In this second quadrant, sign is positive, or sin. Let's call it the sin for today. Sin is positive here. Tangent is positive here. Cos is positive here. So obviously, you know, cos goes with sec, tan goes with cot, sin goes with cosec. The rest here are positive, all positive. Right. Now, the 6 ratios, this is what I'm explaining now. The 6 ratios are explained in a Cartesian plane, which is, this is a Cartesian plane. Note that when we talk theta, we're talking 180 degrees. When we're talking 2 theta, we're talking 360 degrees. That is in radians. Okay. All ratios stay the same. We don't change any ratio. If I've got cos of 180 degrees minus theta, I just check this. I just put a cos here and put an angle. I check this. Is this thing, in which quadrant is this thing? In the second quadrant. In the second quadrant, is the cos negative or positive? There's no cos in the second quadrant, so it must be negative. And that is all that I'm doing. Okay. Show you when we get to the questions. Let's look at this question here. Nice question here. Talks to the radians. So we're given x as a radian. Right? We need the numerical value of this. So of this whole thing. So what we can do, you know, cot is 1 over tan. So I can write this 1 over tan. But one thing I can do with the radians, I don't want to work with radians. I'm working with the cos and the sine and the cot and tangent. Why do I have to work with the radians? Now, I don't want to work with the radians, so how do I change radians to degrees? Listen carefully. These are radians. So it means that I need degrees, so I'm going to draw my division line. These are radians. At the bottom, I write radian. So the radians will be pi. On top, I write degrees because I don't want radians. So the radians and the radians will cancel out. So I'm going to say 180 divided by pi. That's what I'm going to do. Now, if I do that, I'm going to get degrees. So if I go on my calculator and say 180 degrees divide by pi, where's my pi now? Shift pi. Then from there I say multiply by 1,271. Then I get my degrees. So my degrees will be 72.82 degrees. Right. So this is in degrees now. So I'm going to take this and say tan into 1,271 multiply by 180 degrees over pi. Then from there, I'm going to say plus 11. Okay. So this whole thing there gives us cot of x. Cot is 1 over tan. So in this case, just take out a calculator, punch it in, that you get your 11.31. That is your final answer. That's your numerical value of this. If I go and punch into 1 over 10, 1,271, I'm not going to get it right, because you're working with the ratio that needs degrees. Because remember that those ratios, they work with degrees. Okay. Right. That's trick for you. First question, you'll see it is calculator work. So in other words, we use a calculator in that question. Okay. In the next question, they say in the diagram P, X, and Y, that's X and Y. OP, from O to P, that is R. If I'm working in a unit circle, that is my R. Right. So in this case, they call it OP. A is, there's a bracket here, 0 and negative 12, which I think is correct. Then theta lies in the fourth quadrant. You see now that angle here is lying on the fourth quadrant. You see? So it's fourth quadrant here. So now the X and the Y, that's what we need. Right. Coordinates of P. I don't think the coordinates of P will be a difficult thing to do. What will be the coordinates of P? This line here, we can see that line there, it will be parallel to that. Then from there, the value of X here must be there, so we don't have it. The value of Y there will be negative 12. Right? So I already have the value of B there, which is negative 12. Then I've got the Y, I've got the R. So I need the X. So if I need the X, what do? Use the theorem of Pythagoras. Why am I using the theorem of Pythagoras? Because this is a right angle triangle. Now, in this case here, the X value, I don't have. The Y value I have, it's negative 12. The R I have is 13 squared. So I'm going to have X squared equals to 169 minus 144. 12 minus 12 squared is 144. Transposed is 144. So X squared will be equals to 25, and my X value will be equals to plus or minus 5. Then with these two values here, so I must decide which one I'm going to take. Remember, if I take the square root, it's plus minus. Only for the X and the Y, the R, always positive. So now I know it's 5, but I know it's in the fourth quadrant. They said the theta is lying on the fourth quadrant. On the fourth quadrant, the X value will be positive because it's there. Right? So meaning that X there will be 5. If you put a negative, we are saying this value will be on the side, you see? Right. The P value, now we got the P value, the P coordinates 5 and minus 2. Right. Now here I know I've got a 13, I've got a 5, I've got a negative 12. For the right angle triangle. I've got my angle which is in the fourth quadrant. Now, evaluate cos squared theta minus sec square of theta. So the cos of theta, if I'm here, cos will be adjacent over hypotenuse. So it will be 5 over 13, which is positive. I know cos in the fourth quadrant is positive. The sec of theta, oh yes, it's easy. So it's just the opposite of this. So it's just the 13 over 5 all squared. Just take a calculator, punch this thing in a calculator. The answer will be negative 6,61. I think that's what I've got here. Please, here's another tip. If I need a ratio, I do not write cos squared and I write 5 over 13. That is wrong, completely wrong. completely wrong. We're going to mark it wrong at the marking center. Do not write the ratio cost, and then from there you write down the number in the brackets. Just write 5/13. Leave out the cost because we have already written the ratio. So please do not do that. Right. Bad habit. 4.3. This is trig equations. And we are allowed to use a calculator here. Lovely. I know you love your calculators. We are allowed here. So then, what do I have here? -7 tan beta plus 3 equals to 1. So here, what I do is, first I must isolate the tangent of theta. So everything else, that's it. So I'll have -7 tan of beta equals to 1 minus 3. First, I transpose. Then you have -7 of tan of theta, of beta, equals to -2. Then I divide by -7. Remember, I'm isolating. Ratios on the left, numbers on the right. Ratios on the left, numbers on the right. That you must know. Then I'll have a beta equals to 2/7. Right? From there, I use my calculator because I love my calculator. Beta equals 2. They said we need angles between 0 and 180. So in other words, angles between 0 and 180. So these angles, I don't need them. Must read that instruction here. Okay, it's the restriction. So if I use my calculator there, the angle that I get is 15,9. Right? This is the tangent, it's positive here and there. So in the first quadrant, 15, that will be in the first quadrant. Okay. Right? So the other angle will be here, 180 plus 15, but because I'm stopping at 180, so another tip, check your restriction to say this angle must be between which and 2 angles. Okay. All right. Now, this is a question where I want everyone to get, if it's 7 marks, everyone must get 7 marks. Very easy question. Very, very, very easy question. Let's do. We're going back. So if you're doing this question, please, you must draw this and say 180, 360. These are the only 2 angles you write. You say 180 plus 180 minus 360 minus 360. That's all that you do. Then you write the ASTC, right? Now, we're going to start. Don't first ignore this for now. I'll explain why. Cos 180 plus. So you go to your sketch. 180 plus. Is there a C there for cos? No. If it's not there, what do you write? Minus. Then you write your x. Then you put this. Now that square comes in now. See. Then you go to your 360 plus. 360 plus first quadrant. All of them there are positive, which means that that sign here is still going to be positive. Put it in bracket. Multiply by sine x, you don't do anything with that. Tan squared x, I don't do anything about it because it's already reduced. Already I've got 1 mark, 1 mark equals over 180 degrees cot. Remember this one, it's tan and cot. Now 180 degrees plus 180 plus in this quadrant. Do we have cot here? Yes. If we have it, it stays positive. 3 marks. Multiply by what? Tan of x. This tan and that tan cannot divide because there's a plus sign in between. If I've got 1 plus 2 over 2, I can't say 2 divides into 2. I know there's one teacher who doesn't want me to say cancel because they don't cancel, they divide. So they divide, so make sure that you say it's divide. So this tan squared cannot divide with that, there's a plus sign in between. So here, then we say minus cos x that the square cannot be on the x, sorry. It must not be x squared, it must be cos squared x. Now this is plus sin x times sin x will give us sin squared x plus tan squared x all over the cot x can be written as 1 over tan. I know some of saying, why are you not changing the tan to sine and cos? You can do that, but you're going to complicate things, right? Now, then I have a mark for that. I'll have a mark for multiplying out that. Then I'll have a mark for saying cos squared x plus sine squared x is 1. Remember that you must go and look at those identities. 1 plus tan squared x. All over. Now these two can divide. Then I'm left with 1. So 1 plus tan squared x. I know some of you like to leave it there, but we know when you go to the identities, that will be equals to sec squared of x. Right, go and check it on the identities. It is written exactly like that. Right. Okay, now we're going to take 2 minutes break, then we'll be back. Hey, welcome back, my boys and girls. Now, as I said in this question, everyone must get this right. For all the reduction formula, you definitely need to get it right. This 6 marks or 7 marks, it's a giveaway every year. It's a giveaway. We must get it right. Right. So if you've got this 7 marks, you've got 3 marks for the ellipse, and then so already you have 10. So you move it. nicely. We've got the gradient, we've got the distance formula, we've got the inclination, we've got, so all those things, they add up. We're getting there to 45, hashtag 45 as a minimum mark, but we want everybody to get marks above 90 for this paper. Right. Given these functions, you're given now the graphs. So when the equations are given, it's quite easy to draw this graph. Very, very, very easy to draw this graph. You have a calculator with you. Don't understand why we're not getting full marks. Each and every learner in the province must get this full marks if the equations are given and they're asking you to draw that graph. Between 5 marks and 8 marks, we really need to get to do better with this type of graphs. Given the function sine of x plus 45 degrees, and the g of x is 3 cos x, the graphs must be drawn from 0 to 360. You'll be given a grid. So you'll be given a grid like that to say, this is where you're supposed to draw the graph. And that's quite easy because the grid is given for you. I can see there's a 45 degrees, there's some kind of a guide, which means that my degrees, I can write 45, I can do my intervals of 45, 90, 135 and all that. Okay, that's just a guide on how we can draw those graphs. Now, write down the period of f. Now the period of f, here's the graph there, the period of f. So what will be the period of f? So a period of f is not a coordinate. Okay, so the period of the f is from where is this graph up to where is that graph, the full graph there. And I can see the amplitude is 1 there. So it means that the full graph there, this graph will complete at 360. It's just that number. Okay, so if this one was a 2, for instance, that will be 360 divided by 2. If it's a 4, it will be 360 divided by 4. So it's just that number. Okay, so this is 360 divided by 1, which is 360. It's a period, please, my boys and girls. Okay, so don't write like 0 and 360. Even if this one was 180 degrees, the full graph will finish at 360. Okay, the full circle of the graph. So if that amplitude is 1 here, what is the amplitude? Is that number that is there. So that number that is there, sorry, that is there. So in this case, the amplitude is 1 for that graph. What is the amplitude of that graph there? It's 3. So the amplitude is 3. Right? Please, just write the number, amplitude, 3. Just write 3. Because this number, this is the number that is there. So just write it as it is. Okay, so please make sure you get these marks. These are just free marks. These are free marks. Right. As long as you understand the question. In the next one, they say draw the sketch. So what I'm going to do, they will give you the grid. Please, in this case, I did not include the grid. They will give you the grid. So if I quickly want to draw this, so I'll have my 45, 90, 135, I'll have 180, 225, 270, 315, and 360. So meaning that my graph is going to stop there at 360. I'll have 1, 2, 3, I'll have -1, -2, -3. Right. Okay, and that's my 0. So for me to draw this graph, then I can use my calculator. So just use a calculator. You can even do a table. So for instance, you can even draw a table. On some of you, I know your teachers have taught you on a calculator to say you go to f of x, and then from there you input the 2 graphs, then from there you just get those values and then you just put them there. So for instance, in the first one, so I just input the graphs there. So it's 0, so I'm just going to put 0 on the x to draw the first graph of f. So I think the graph, it will be 0.707. I'm not going to plot all those points in there. Sorry. So at 45, it's going to be 1. So it will be there, sorry. It will be at 1. So the graph will start there. And from there, it will go to 90. At 135, it will be somewhere there. At 180. At 225, it will be at -1. At 180 degrees, it will be somewhere in there. At 135, so it will be there on 135. Sorry about that one. So this graph will go like that, and it'll go there, and then from there 270, I think it will be there. So it will be at 315 degrees, and then from there it will go somewhere there. So this graph will look like that. So you just put all those points in there, and then you'll have a graph like that. Okay. For the 3, so for the G graph, so there's no child without a name. Please just name the graph. On that one, so it will be at 90 degrees. And then at 180 degrees, I think it will be at -3. Then we'll pass at 270 degrees, and again at 3. So it will be going like this, and then from there it goes there, and then it goes there, and it will be a G graph. So if you input this on the calculator, you are able to pick up the points. So you can do 90, 180, 270, and 360. You can put those. For intervals, you put 45. So intervals will be 45, so you can use the 45 and that. You can put it on a table, just do it manually with a calculator, because these are 3 marks that you must get. So for you to get all these marks, you must make sure that your calculator is on a DEG mode, it's on a degree mode. Okay. All right, so with the graphs, do the questions that you can be able to do. In the first hour, do the questions that are easy. They're easy to do. Then from there, you then go back to those tough questions. You know, those other questions, they're not tough. They're just that somehow you did not practice them well or did not understand. So you go back to them, some things will click in, and then from there you say, oh, I've seen this before. Mr. Maudu was doing this before, then you've seen it before. So you do it. Okay. Now, let's get to the geometry. The biggest tip that I can give you for geometry is to work on the sketch. You go to your exam guideline, you go and look at, for the whole weekend, you go and look at those reasons. I know it's going to be a lot of work to do, but please go and look at some of these reasons. Just take a question, put it here, look at the reasons. Look at all the 9 theorems and look at the reasons. Then from there, you'll be able to give the rest. But I want to work on the sketch first. I'm not going to work. First of all, I'm going to complete this. In the diagram, circle PQRS, PQRS, those are points on the circle. Q2 is 48. Okay, that's given. S2 is 21, that's given. Complete the following theorem. An angle subtended by the diameter. So they're giving you the answer there. Here's a diameter. Here's an angle subtended by the diameter. That angle will be 90 degrees. Already I've got one angle. Angle subtended by the diameter, that angle here will also be 90 degrees. Obviously, that will be a cyclic quad, opposite angles supplementary. All right. So here, you just say 90 degrees, or you can just say right angle. So one tip that I can give you is that you must go and learn all these theorems. 9 of them. Go and learn them. The weights, it's 1 mark. It's very important. That mark is very, very important. If you can get 99 out of 100 and you missed out on that part, it will be a big, big, big disappointment from you. So please go and learn that to get that 1 mark. Learn the weights of the theorems. Right. The second one, I know that this angle is 90. That angle is 90 here. Now it says, let's get Q2. Oh, state reasons. Stating reasons, right? Two more angles with the same size as Q2. Q2 is 48. Now, I'm coming to my sketch now. This angle here is 48. First of all, there's an angle at the center, twice angle at the circumference. So that angle here is 96. Right. Angle at the center, twice angle at the circumference. But there's a bow tie here. Please don't write bow tie. There's a bow tie here. I can see that angle here and that angle there. Can you see? This angle here and that angle there. They are equal. So which means that P2 is one of the angles that are 48. The reason will be angles in the same segment. Same segment. Please don't write bow tie. Angles in the same segment. When we are still seeing a lot of bow ties in the exam, in your papers at the end of the year, we don't want to see that. What is the other angle that is going to be 48? If this is 48, this line and that line here are radii. So if they are radii, meaning that S1 will also be 48, because this line here equals to that line. So S1 will also be 48. The reason will be angles opposite equal side. Now, boys and girls, this is the only reason, acceptable reason that is needed here. No any other reason except angles opposite equal sides. If I'm given the angles and I need to say these two lines are equal, it will be sides opposite equal angles. So please, these are the only acceptable ones. No any other reason will be accepted. We are very strict with the reasons. If the reason is not correctly put, you are not getting any mark. That's where we are extremely this is very important for you to understand. We are very strict with marking that type of question. Let's see O2. I already know that this is 48. This is 48. This is 96. So now I need O2. So O2 is this one. Oh, I already have O2. No problem. O2 will be 96 degrees. What will be the reason? Remember, I was speaking with the reason will be exterior angle of a triangle. You just stop there. It's an acceptable reason. R2, so I need R2. How am I going to get R2? I know that Q2 is 48. Okay, so I need that Q2 is 48. Am I looking for R2? So S3, how much will S3 be? Because this whole thing will be 90. So S2 will be 21 degrees. 21 degrees, right? So I know that that angle here, this angle there, right? So it will be the sum of angles in a triangle. I've got 48 here, I've got 90 there. What will be the angle there? So R2 will be 42 degrees. Why am I saying 42? Because this whole thing is 90 plus 48 in a bigger triangle there. So that should be 42. So it will be sum of angles of a triangle. Sum of angles in a triangle. All right. Okay. So I can still do it with Q2, it's not a problem, so I can still do it with Q2. So there are so many ways of getting this angle, so I can be able to get that value of R2. Okay. Right, S3, we know this is 42, this is 48, 48, 96, This is 21. So I need S3. Oh, I already have S3, 21 degrees. So I have S3, 21 degrees. So there's no problem with that. So S3 is 21. So what will be the reason there? So my reason can be that whole angle S1 plus S2 plus S3 will be 90 degrees, okay? So in my reason there, I can just say angle in a semicircle. Because that is the angle in a semicircle. This is the diameter, so there's the angle in a semicircle. I have this, so I can get S3. Okay. P1. How am I going to get P1 now? So I know that P1, if I do this, P1, you see that? So it's my bow tie again. You see that? My bow tie again. Nice. So if this angle is 21, that angle will be 21. So P1 will be equal to S3, and it's also going to be 21 degrees. And the reason will be angles in the same segment, or angles subtended by the same chords or same arc. I can just say angles subtended by the same chord or angles subtended by the same arc. Okay, so the geometry, it needs a practice. It really needs a practice. So just take 2 or 3, 4 writers, work with them, see, open your exam guideline, check the reasons, see if you can connect the reasons, and probably can get some few marks out of geometry. Don't leave blank spaces in geometry. Please don't. So let's make sure that we at least practice 3 or 4 writers. Then, because you don't have to prove anything, that this angle equals to that angle, you just make sure that you understand the reasons and the statements that you're putting by using the 9 theorems that you've done. Okay. Right. The next activity, complete the following statement. As I said, now you are seeing you have another one mark. A line to one side of a triangle divides the other 2 sides proportionally. The word that is missing there is, I can hear all of you saying parallel, the line drawn parallel. Remember, the line drawn parallel to one side of the triangle divides the other 2 sides in the same proportion or proportionally. Right. Look at the question now. It says, given triangle IJK, LN, this line, it's parallel to JI, and LM, it's parallel to KI. Prove stating reasons, these 2, that there's a triangle here, triangle there, that the 2 triangles are similar. For them to be similar, they must be equiangular. In other words, their angles, the corresponding angles must be equal. And their sides must be in the same proportion. The easy way to do it will be with the angles. So I must prove, I must say in triangle NKL and triangle IKJ. Look at this. First of all, I must shade the triangle. But please do not shade them do not use your highlighter in your answer book. Very important. Shade them there. Just shade them. Pencil, whatever. Different colors. NKL is this triangle. I'm shading that. IKJ is the bigger one. I'm shading it like this. Can you see it overlaps also on the smaller one? Right? This is the triangle. Enjoying drawing this. Right? Now, is that small triangle here and the bigger triangle there? Right. What is common here? I can see this angle here appears in the small triangle, appears in the bigger one. 1 mark out of 3 already. So I'm writing, first thing, angle K is common. 1 mark, done. 1 out of 3. I'm good to go. First. Number 2. Why did they give us this? Means that I must use it. This line here is parallel to this line. So parallel lines, I know that alternate angles, corresponding angles, pointary angles. In this case, N1 and angle I are equal. So I'm going to say N1 equals angle I. And these two are corresponding angles. They are equal. But now I must write down the lines that are parallel. NL and JI. Okay, good. If you don't write these parallel lines, you're not going to get a mark for this. Okay, if you write corresponding angles only, you're not going to get a mark if you don't write parallel. Number 3, it's obvious. So in other words, what is left? A done, N1 done, what is left? L1. L1 and J. These are also corresponding angles, but I can just write third angles. Okay, I then say therefore, triangle NKL is parallel to triangle IKJ. Reason, angle, angle, angle. What does this mean? It means that this angle, that angle, and that angle. It's 3 of them. Angle, angle, angle. In similarity, it's angle, angle, angle. Please, you must make sure all the sides can be corresponding. Okay? Right. The next one here, it says if JK, where's J? JK, that whole length here, it's 5. I'm going to write it on the side. And then NK, it's not the length, please, it's not the length. So I'm going to write this 5K. Right. And NK, it's 2K. Right. Small letter K. Let me just write small letter R. All right, just use R, different from the K and the, because there's K there. Now they say we must determine the length, the value of NL over IJ. What will I know about that? That the length of NL over IJ from similarity. It will be given that. From the similarity that we had. Remember, we said triangle NKL, it's similar to triangle IKJ. Then I can use this. From the similarity, I can say NK over NK over IK. It's equals to NL. Tell me the denominator there. If I say NL, what should I say on the other side? IJ. Right. So if I look at NK, what is NK here? It's 2R. What is IK? I mean, IK there. So do you have IK? So that will be the same as over 5R. So you can see that NL over IJ will be the same as 5R over 2R, and I can cancel this 2. Therefore, my NL over IJ will be 2 over 5. All right. So now, in this case, you have that as a ratio. It is not the length. There is no length here. So it is just the ratio of NL over IJ, and this is what we are looking for, which is going to be 2 over 5. Right. Now, in this one, you're given that JK it's 5 and NK is 2. Already I know that this over that is 2P over 5P. I'm just going to write that. This is R and that is 5R. I'm going to write it like that now. Now we're looking for JM over JI. So now, first I'm going to write JM over, remember now I'm using this now, JM over JI, it's equals to JL over JK. Now this is the prop theorem. Now with the prop theorem also, you must write it as the parallel lines that are there. So the parallel lines is going to be LM, it's parallel to KL. Right. So if I say this, so that this over that, it will be the same as this one over that one. So if this is 5, the whole line is 5, and this one is 2R, which means that that line from here to there is going to be 3R. I'm going to circle it there. Now, let's check the next one. The next one will be JL over JK will be the same as IN over IK. This is also the prop theorem. Let me write it properly. Prop theorem. But now it's going to be the other two parallel lines, which is LN parallel to JI. Okay. Therefore, we can then see that JM over JI will be equals to 3, as I say, JM over 5. So it will be 3 over 5. Right. Now, this is, as I say, it is not the length, it's also the ratio of it. Okay. So you just need to look at the parallel lines. If this line is parallel to that, you will have this over that equals to this over that. Or I'll have this over the whole equals to this over the whole. Okay, so that is the answer for JM over JI. Now, if you look at the circles, angles, and angular movement, your favorite, because the formulae are also given there, very simple questions here. Now, it says a home fan, it's very hot nowadays, so each and every home has got a fan. The fan here has got a diameter. See, from here to there, it's a diameter of 25 centimeters. It's in centimeters. Just short 5 centimeters to be the length of the ruler. Now it says it rotates its blade at 200 revolutions per minute. This fan is rotating, bringing in cooler air in your room. What is the diameter of the fan? So the radius is given as 25. Simple question. Diameter. What is diameter? Diameter is twice the radius. Which means I just need to multiply the radius by 2. And there will be 50 centimeters. So meaning that from here to there, it's going to be 50 centimeters. Okay. In 8.2, they'll say calculate the rotational frequency of the fan. I know that the rotational frequency is 200 revolutions per minute. So it will be this over 1 minute. Now I want it in seconds. So it will be 1 over 60 seconds. Right, I need the rotational frequency. Remember, the rotational frequency will be revs per second. Per second means the seconds must be the denominator. I calculate this correctly, I'll get 10 over 3 revs per second. Right? Don't multiply it by 60 because you're not going to get revs per second. Remember, this is revs, these are per seconds. Okay? Right. These are revolutions, 200 revolutions. So dividing it by 60, you get to seconds. Remember the circumferential velocity. If you go to your formula sheet, you get this word here. And it's connected to a certain formula. So you just write down the formula. V equals to pi d n. And it's written. The d is the diameter, n is rotational frequency. Substitute. That's all. You get 1 mark for the formula. Substitute. Pi diameter. Now they want it in meters. Can you see? That's where we get it wrong sometimes. If they want it in meters, which means what we have been given, the diameter is, we have got the diameter is in centimeters. So we must take it to meters. So know your conversions. So we have to divide this by 100. The rotational frequency, we got it. It is per seconds. Then we multiply this. Use the calculator, you get 5.23 meters per second. Write down the units. Please, there will be a time when the units will penalize for the units. Please do write down the units. The angular velocity, you go to your formula sheet, you get that word here, and then connected to this formula, omega equals to 2 pi n. That's an easy one. 2 pi multiplied by the rotational frequency, 10 over 3, and then just use a calculator. These are 6 marks, simple, straightforward. So you get 20.92. Remember, these ones are angular velocity, it's radians, because remember, these are radians, it's 360 degrees. It's radians per second, because this one is in seconds, right? So it's radians per second. Write down the units, please. Okay. So this type of question, then you go and practice also the arc length, the area of the sector and all that. So those are some of the questions that you get. The last question that we're going to do for today is a basic question that we know. Please, if you get it like this, please make sure that you get this question right. Now it says, the irregular shape as shown below has one straight side, 120 centimeter long. It is divided into these parts. How many? 1, 2, 3, 4, 5, 6. So which means that 6 equal parts, which means that the ordinate, the length of the equal parts is going to be 120 divided by 6 centimeters, which is going to be 20 centimeters. So meaning that this will be 20 centimeters, 20 centimeters, 20 centimeters. That is A. You go to your formula sheet, you will see it is written A, it's equal parts. Written like that. Right. Then the next question, it's obvious, calculate the area. But please, let us read the question. Some of the questions are not going to come as this. Sometimes you might be given, this might not be given, and then they give you the area and they want you to calculate one ordinate. So meaning that the A will be given, one value of the X will not be given. Write down the formula, and I see I'm saying it again this year, that 80, the formula that you write here must be the formula that you're going to be using. For substitution. We see a lot of this thing happening whereby the formula that is used here is not the same formula that has been used for substitution. All right. And the ON minus 1, please do not put the last value like 46 and you see 46 minus 1. It's incorrect. It's just the value before the last one. So just keep it like it. Is this value before the last? So just put it as it is. The A value is going to be 20. O1 plus ON. So it will be the first and the last. So it will be 16 plus 38 all over 2. We see mostly you write down this formula. From there you then write down the substitution is for the other formula of M1 plus M2. Then O2 is going to be 70. Then we have O3, which is 64 plus 50 plus 58 plus 46. Running out of space there. Then from there I'll have use a calculator 6,740 centimeters squared. Remember it's area, so it must be 7. It must be squared. So these are type of questions that you must go and practice. If it comes like this, if it doesn't come like that, then the area will be given, and one of the lengths will not be given. You get the value of the length. But read the question, understand the question. Make sure that you reread the question and understand it. That was the last question. Thank you so much for tuning in, and good luck for all the learners who are writing Technical Mathematics Paper 2 on Monday. You've got this. Thank you so much.